Welcome to Washoe County School District's 21st Century Learning Division's webinar series on the 6 dimensions of 21st century learning. Today's focus is on knowledge construction. My name is Misha Miller, and I will be your presenter today. Today's objectives are to look at 21st century learning dimension of knowledge construction in greater depth and to explore examples of what each of the competencies within knowledge construction could look like at the classroom level. I know that you've become quite familiar with our planning document for the 21st century learning competencies, and today we're going to highlight the dimension of knowledge construction. And as you elevate on the planning guide with your planning and instruction, your students are integrating knowledge construction to a greater depth. Remember, in order for students to demonstrate interdisciplinary, the other competencies below it must also be achieved. So why should students construct knowledge? Why should knowledge construction be included in your classroom lessons and activities? Many have referred to the modern world economy as a knowledge economy, in which the possession of knowledge is far less important than the creative uses of knowledge. In this knowledge economy, the development of new knowledge is the greatest driver of innovation. In fact, most living wage jobs today demand content area expertise, but also the ability to apply knowledge to new situations and new problems. More than any other time in history, knowledge is at our fingertips, especially through internet-connected mobile computing devices or smartphones. And while the internet is not all-knowing, it is indisputable that virtually any fact, figure, procedure, or resource can be located almost instantly by just about anyone. So teaching students for mere recall of facts and mastery of procedures seems a narrow outcome for 12 years of schooling. But preparing students with knowledge and the ability to construct future knowledge through critical and applied thinking, what some call deep learning, is a key feature of the Nevada academic content standards and will better position our students as productive contributors to a knowledge economy. So what is knowledge construction? The generation or thoughtful creation of new ideas and understandings lies at the heart of knowledge construction. By focusing on the process of creating ideas and carefully considering their value, we can become more skilled at thinking critically and creatively. But how do students thoughtfully create or generate new understandings? And how can we expect our students to regularly come up with new ideas? In the context of learning, it's important that we think of new ideas and understandings as those that are new to me. Just as when I purchase a pre-owned vehicle, it is new to me. When we encourage students to generate new ideas, we are not concerned with how earth-shattering the ideas are. We are far more interested in the process by which students generate these ideas. For instance, a student who has created and tested a mathematical strategy is far more likely to have developed a deep, transferable understanding than a student who has observed a few worked solutions and then completed the odd-numbered problems on page 413. Knowledge construction cannot be achieved when students merely reproduce what they have already learned. Doing more of the same thing over and over does not contribute to learning. Quality over quantity is the guiding mantra. So how do we plan instruction that includes opportunities for students to construct knowledge? If knowledge construction is a process by which students generate ideas and understandings, the focus of classroom instruction should be on helping students to learn and experience this process. Learning activities that are higher on the knowledge construction elevator give students more opportunity to construct ideas, connect them to other content, and internalize understandings. Activities that require students to generate ideas typically include one or more of the following, and that's why we've included this image on this slide of the Bloom's taxonomy. Interpretation means drawing inferences beyond the literal meaning. For instance, students might read a description of a historical period and infer why people who lived then behaved as they did. Analysis means identifying relationships among the parts of a whole. Students might investigate local environmental factors to determine which are most likely to affect migrating birds. Synthesis means identifying the relationships among two or more ideas, so students might compare and contrast perspectives from multiple sources. And evaluation. So evaluation means judging the quality, credibility, and importance of data, ideas, or events. Students might read several accounts of an event to determine which they find most credible. It's important, too, to consider that the generation of new ideas and understandings cannot be achieved by following procedures students already know. When activity requires students to devise procedures themselves, the activity qualifies as knowledge construction. Turning to the 4 levels on the knowledge construction elevator will help us identify how to build the opportunities for knowledge construction and critical thinking into instruction, and engage students in their development of the 21st century learning dimension of knowledge construction. So as we looked closely at the 21st century competency planning guide, we saw that there were 4 competencies within the knowledge construction dimension, and the first of which is that knowledge construction is required. An activity requires some knowledge construction when students go beyond reproducing knowledge to generate ideas or understandings that are new to them. Some key considerations of this competency are that most activities that require some knowledge construction ask students to interpret, analyze, synthesize, or evaluate information or ideas, and that most activities require some knowledge construction ask students to devise procedures for conducting their own work. Practicing procedures students already know or following a prescribed set of steps does not qualify as knowledge construction. So an example of what this could look like in a math classroom could be an exploration activity where students try to construct triangles with different size squares. making observations about when they are and aren't able to construct a triangle. So as the students explore, the teacher may ask students what they notice. What do you notice about the side lengths that do not make a triangle compared to side lengths that do make a triangle? This is a diagram of what a student might construct with 3 side lengths that do not form a triangle. And as the teacher who's facilitating their learning, you might ask individuals or groups of students, why can't they form a triangle? And this exploration activity helps students to construct knowledge on the triangle inequality theorem. So you're helping them to discover this on their own instead of supplying them with the inequality or the theorem. So the first competency was that knowledge construction is required of students. To bump that up to the next level, the next competency requires that knowledge construction is the main requirement. So the activity's primary purpose is knowledge construction. When students go beyond reproducing knowledge to generate ideas or understandings that are new to them. And the main requirement of the activity is the construction of knowledge through interpretation, analysis, synthesis, and/or evaluation. Some key considerations for this competency are: when determining if an activity's primary purpose is knowledge construction, students' time and effort should be considered. When looking at time, most of the students' time should be spent on generating new ideas or understandings. And effort, most of the students' effort should be spent on generating new ideas and understandings. And this should be evident in any product of learning. The following actions of the teacher should also be considered when determining if an activity's primary purpose is knowledge construction. Coaching students through their development of learning processes rather than providing answers. Incorporating the generation of ideas into expectations and grading, and establishing classroom environments that activate feedback from many different sources. So if we took our initial example where students are exploring and looking at which side lengths make a triangle or form a triangle and which side lengths do not, we can extend that activity and bump it up by also asking them to construct triangles with different sized squares to determine the characteristics of acute, obtuse, and right triangles. So, for example, and this isn't on a piece of paper that's provided to them, but asking the question a lot in your class, what do you notice? Students are trying to look for patterns, they're trying to discover things, asking them, what do you notice? So as the teacher is wandering around the classroom and facilitating the student learning, they might ask, when you compare the side lengths of the triangle you constructed, what do you notice? Or when you compare the squares of the triangle you constructed, what do you notice? Or referencing a triangle that they've already built and comparing and contrasting it to new ones that they've built. But the focus of their time and effort for this activity is built on their understanding of the relationship between the different sides of the triangle and helping them to discover a pattern. So the first competency was that knowledge construction is required by students. The second competency is that it's the main requirement and most of the students' time should be spent on that knowledge construction. The third competency, as we elevate up the elevator guide in the specific dimension of knowledge construction, is that it is applied knowledge. So students apply their knowledge when they use knowledge they have constructed to support another knowledge construction task in a new context. The second task deepens students' understanding of content because they must apply their understanding in a different situation. Students must consider their knowledge and ideas from a different point of view, leading to transfer of learning and abstract thinking. Some key considerations. To qualify as a new context, the two contexts must differ substantially from each other. For instance, students who constructed knowledge about the principles of heat by studying the Earth's core might apply this new knowledge to a study of Jupiter. And to qualify as an application of knowledge, students should apply knowledge in a different way in the new context. For example, students might write a persuasive essay for an academic audience, then use their constructed knowledge about persuasion to rewrite the article as a newspaper column for a general audience. Note, to qualify as applying knowledge in a new context, the learning activity must also meet all the requirements of constructing knowledge. So if we reference our example and look at how we can take this learning and extend it to take it to the next competency level, we might present the students as a designer. So they are a designer and they've been asked to design a kitchen space that is 10 feet by 10 or 20 feet. The designers recommend positioning the refrigerator, stove, and sink in a triangular pattern. So which type of triangle creates the best design pattern, and draw a scale model. So we're asking students to apply their understanding of triangles as a designer and to create a pleasing design and draw a scale model of it. To bump it up again and elevate it to the next competency, we would include interdisciplinary. So interdisciplinary learning activities have clear learning goals that incorporate content, ideas, and methods from multiple academic subjects. Some key considerations. To qualify as interdisciplinary, the activity must include substantial content, ideas, and/or methods from at least 2 academic disciplines. And reading and writing should not be considered separate disciplines. And technology should not be considered a separate discipline because it is a tool. Assessment processes, including formative processes such as ongoing feedback, should focus on at least 2 academic disciplines. And clear learning goals from at least 2 academic disciplines should be communicated to students. Importantly, interdisciplinary activities must require students to apply constructed knowledge in new settings in at least 2 academic disciplines. So they've learned and constructed knowledge maybe in English about something, and they've learned constructed knowledge about something in math, and now how can I take both of those understandings and apply them in a new context? So if we continue our example and tweak it just a bit, so they're still the designer, And they've been asked now to come up with a design proposal for a kitchen space that is 10 feet by 20 feet, a rectangular space. And they know that design experts encourage positioning of the refrigerator, stove, and sink to be in a triangular pattern. They're asked to create a scale model of their kitchen and to explain why the type of triangle they chose is the best design pattern, and to do that in a short persuasive essay, why their design is the best, explaining their mathematical understanding of triangles, and why the person should hire their design team to design their kitchen. So the key here is that they're bringing in a focus and an element of their math understanding, as well as their understanding of persuasive essays. And this activity targets learning goals for both math and writing. So some final thoughts on knowledge construction. Activities that foster knowledge construction require students to use critical and creative thought processes to generate their own understanding. Allowing students some flexibility in the outcomes of their work and the means they use to develop these outcomes provides them with opportunities to develop and practice the thought processes that lead to construction of knowledge. Virtually all work in the real world is interdisciplinary, requiring people to blend content knowledge and concepts from many disciplines to develop applications of knowledge in new contexts. Interdisciplinary learning activities, therefore, provide the greatest scope for students to develop the 21st century dimension of knowledge construction in preparation for their entry into an economy in which knowledge is a critical commodity. It may be helpful for you to take a look at the Knowledge Construction Elevator Guide linked here. It is basically the transcript of this webinar, in addition to concrete examples of learning activities for each competency. Thank you for your time.